Yeah, thanks for this nice introduction, and welcome to the session about NLP, in particular transfer learning in NLP. Right now it's really a super exciting time to work in NLP, but it's also developing at such an incredible pace that it's sometimes a bit difficult to keep on track with the latest developments. So I hope this session today will help you to get a bit up to speed with transfer learning in NLP, the latest language models that are actually used for that, and also show you a bit how to use those models in your daily work. In my daily work, I actually deal with both sides of NLP. On the one hand side, research, and on the other hand side, the industry. In research, these days in NLP, I would say it's a lot about transfer learning. All conferences are basically flooded with papers around that topic. We see new language models basically on a weekly basis. And also there's new state-of-the-art performances published for downstream tasks like question answering or some natural language inference. On the other hand, we have the industry. And they have quite some different requirements when it comes to NLP, be it just deploying at scale, different data, different domain language. So there's quite a gap between those two sides. And in my daily job, I basically try to bridge that gap from industry to research. And that's why 2 years ago we founded dissect, a small startup in Berlin, where we try to do exactly that. And we do that basically with 3 different approaches. On the one hand side, we have open source software and models that we publish, free for everybody to use, free for all developers. And then we have on top of that some enterprise features that you really need when you want to deploy at scale. And we do some custom development and consulting. I'm not sure what's happening with the screen, but I hope it will be back soon. Here we go. All right, yeah. So that's basically my daily job. For today, I would like to go a bit through transfer learning, explain a bit the major concept, the idea behind it, then look at one core component of transfer learning, the language model itself and different variants of it. Then going over to some application, tasks that I'm super excited about these days, question answering, because there we really see the biggest improvements, and then finally giving a summary and a bit of an outlook. So what is transfer learning? The basic idea is pretty simple, and I think also yesterday there were already quite some talks about it. It's basically you take one huge data set, train a model on that, and this model acquires some kind of knowledge, let's say. And this knowledge you want to then transfer to a different task, to a different model. And by doing that, you actually need then a way smaller data set for your second task. So the model not only learns from the second data set, but also has some kickstart basically with some prior knowledge. That's the basic idea. The advantage of that is mostly you need less labels for your task and you get a better performance. This is, I would say, pretty much the sweet dream of every machine learning engineer, better performance with less labels, and it also enables a lot of applications in the industry. 2 other advantages that are not mentioned that often, but are for me quite important. It actually also has a big implication on your development cycle and your development style. We experience that it really accelerates your development work. It's just faster. And on the other hand, it gets more standardized, and it lets you reuse a lot of components across projects, across different tasks in your company, which helps a lot to leave these silos in NLP. Transfer learning is not new at all. It has been around in computer vision for years, So I guess some of you come from this field and know that there was ImageNet, I think published in 2011, 2012, around that. Huge collection of images annotated with objects, and people use that to train a model. This model learned some basic knowledge, in quotation marks, basic geometry, some textures, and this knowledge was then able to be transferred to downstream tasks, to other applications, for example, classifying screws in the industry. Quite boring task, but that's many tasks in the industry. So people also tried that doing in NLP, and it didn't really work for a long time. What people try to do is also putting in a large text corpora, for example Wikipedia, and learning some kind of model. And these models usually also learn some kind of implicit knowledge, some general understanding of language. It's a bit hard to visualize this knowledge, but it's usually some kind of word embedding, some synonyms that get similar vectors in the space, something about syntax that they learn. And this knowledge then can be transferred to another task, for example in the industry, classifying legal contracts. And people tried that, but it never really worked, or it was not working at a similar scale like in computer vision. Well, the good news now is it's working finally, and I think this is only happened within the last year, and this is super exciting. And yeah, pretty much 1 year ago in November, December last year, there was one model published, BERT, which basically really kicked off a whole stream of development, whole stream of research, tackling this, accelerating this transfer learning stream in NLP. And since this, like only in this last year, it had a big impact on a lot of different areas of NLP. First of all, research. Right now, these kind of models are dominating all, or mostly all, leaderboards. One that I'm particularly excited about is SQuAD, Stanford Question Answering Dataset for the task of question answering. And what we see here is basically the timeline and performance F1 score. And what we see 1 year ago, there was a bump. And this bump was due to this guy, BERT, a model published by Google, which is probably not right now still the most prominent example of transfer learning. But it's not only used in research, but there's also a lot of implications in industry. A few weeks ago, Google announced that they are now using it for 10% of their search queries in the US. And the VP of search stated that it was the biggest positive change within the last 5 years. And this caused a lot of headlines. And I was really surprised on the weekend, read some newspapers, and I saw NLP BERT on the front page of some generic German newspaper. And it really showed me, okay, this is now making the step into the industry. It's not only research, it's not only stuff that you read in newsletters from Sebastian Luna, but it's really getting out there. And actually, I think 2 or 3 days ago, Google announced they're now also rolling it out for 70 other languages, so it's not only in the US anymore. What is remarkable here is not only that Google is doing it now, but at what scale. You have to imagine it's millions of search queries. And a few months ago, everybody was saying, yeah, you know, okay, there's BERT, there's transfer learning, but yeah, there are these transformer models, they are so huge, impractical for my use case. Google is not showing that you can do it if you want and if there's business value for you. And they all did that within 1 year. Last but not least, it also has big implications on style of work for us as machine learning engineers or data scientists. I think the last years, they pretty much felt like a crazy ride building soapboxes. You look for the best model for your particular task, engineered here feature, engineered here additional layers, and in the end you had something that worked. It was super fun. You basically won this race maybe, but it wasn't really sustainable. And I think this is now changing. We go from these individual models, individual silos for each particular task, to a more standardized way of applying NLP, of training models. And I think this is, it's pretty much described by building on the shoulders of giants. So you take these big pre-trained models and apply it or fine-tune it for your particular domain. And this changes the whole style of working. Also more on operational level, we, for example, in our team experienced that we basically completely shifted development from local machines to remote interpreters in the cloud, having GPUs, so not only using GPUs anymore for only for training, but also in development, using that as an interpreter, because these models are super big, and it's just difficult to put them on a CPU and have a good development experience. So how exactly is transfer learning now performed in NLP? What different phases do we have there? There are different styles of transfer learning, but most of the time, right now when people talk about it, it's sequential transfer learning. And sequential transfer learning has 3 phases. The first one, basically taking a huge text corpus and training a language model from scratch on this corpus. The second phase is an optional phase. If you work in some domain where the language is a bit more specific, for example in biomedicine or in some technical engineering environment, then you might want to adapt this language model to a certain domain corpus. So basically continue training for a particular domain. And the third and last phase in transfer learning is then actually applying your model to a downstream task. So basically the task that you're really interested in. This might be named entity recognition, document classification, question answering, search, whatever. So these language models are really the core component in this transfer learning paradigm. So let's have a look into what they actually are about. The idea of language models are pretty straightforward. You have a sentence and you mask out a certain word. And if you read now as a human this sentence, you already think automatically, what is the word missing here in the middle? The fox over the street. And you already come up with ideas about this. And it might be the fox runs over the street, walks over the street, jumps, whatsoever. And this task seems very simple, but it's actually super powerful in the machine learning world. And the reason for that is that you need really to understand context to master this task. And understanding context means that you need, on the one hand side, syntax, but also semantics. You need to understand what this sentence is about from a content perspective, but also the syntax is important. In this example, for example, the runs with an S in English, you need the right conjugation, right form of the verb. The last reason why it's powerful and why it's so heavily used, it's very cheap to train or to create training data. You don't need any humans to annotate your examples. You can just feed in any text and automatically create examples by blanking out words. So that's super powerful. I think in every model out there it's currently used. So let's have a quick look at some demo. These language models can, on the one hand side, be used for generating language, on the other hand side, for understanding language. Right now, let's try to generate some text with that. There's a website called Talk Transformers, which is basically deploying one of the most prominent models out there, GPT-2. It's running not the biggest model, so not the most powerful one, but a rather small version of it. But it's, I think, enough for playing around with it. It's rather fast. So yeah, let's maybe try to feed in some text. Let's maybe say Frodo Beutlin. I don't think it's called in English. It's Baggins. So Frodo Baggins from Lord of the Rings travels to Poland. And let's see what the language model does with that. travels to Poland and much of Italy to bring back his family from Mordor, and is found by elven travelers looking for a country that can help them spread their word of return, and so on and so on. So what's happening here is basically that the model, one word after the other, samples and predicts what comes next. And the interesting thing about this is now that these recent models really managed to keep the context over quite some long sequence. So it means that you really can create stories that make some kind of sense. Often they are also bullshit, to be honest, but at least they are grammatically correct, and they pick up the initial idea also after a few sentences. Anybody else with a sentence that he wants to try? No? Okay. Then, yeah, maybe if you want to play around with it at home, it's super fun. There are different variants of it. So these language models can, on the one hand side, be used for generating language, as we saw, but more often they're actually used for understanding language, for these downstream tasks like entity recognition. And one very prominent model out there, I already mentioned it, BERT, released 1 year ago by Google, and it was basically trained on, or pre-trained with two objectives, two tasks in the beginning. The one is the mass language model, so just what we saw, and the second one is next sentence prediction. We will see that in a minute. It was trained on about 13 gigabyte of data using Wikipedia and some publicly available books. So let's now go through each of these three phases, pre-training, domain adaptation, downstream, and see what actually is done in these phases. And I also tried to give some tips and recommendations that we found useful working with these kind of models in the last year. So when you train from scratch, you basically feed in a pair of sentences, so one here and one here. You mask out some words, and you feed it into the model architecture. On top of that, we have two different prediction heads, one focusing on next sentence prediction, and the other one on language modeling. And this next sentence prediction basically tells you or needs to predict if these sentences come one after the other in the original document or not. In this case, probably not, they don't belong together. And language model fills in the blanks, as we just saw. If you now want to really train such a model from scratch, when is it useful? I would say in probably 80% of the cases it's not useful. It's only useful if your target language is very different from the ones that are already published. So there's a model for English, there's we trained a model for German, and I think now there's no model for Polish, so this could make sense to train, for example, a Polish model. And also in some domains where your domain language is super different, then it might make sense to train from scratch. It only makes sense if you have roughly about 10 gigabyte of text data, I would say. And in your application, it really means having small performance gains from the modeling side translates to big business value. So if you're working in a startup, you have just a small case, might not make sense, but if you are in a corporate with many applications of that, also 1% performance matters a lot. If you do it, I would recommend to train a smaller base model first. So there are always variants, like a smaller model and then the huge ones. The huge ones tend to converge more strangely, or we saw difficult patterns there. The smaller ones are nicer and better to start with. And then these models are usually quite robust in terms of hyperparameters. One single parameter that is not robust is the learning rate. So keep that really in mind. This costed us a lot of money on the Google Cloud because we had to figure that out. So usually it's better to start with some smaller learning rate and then bump it up. So having learning rate schedules, for example, this is crucial. And then one trick that also a lot of people do now is you actually have to define a maximum sequence length that you feed into this model. And the longer the sequence length is, the more computation you need in this model. It's actually quadratic. So what helps is that during your training from scratch, you do 90% of the training actually on quite small sequence length, quite fast. And then with the last 10%, you do on the really long sequence length. This is enough for the model to also deal with the longer ones, and it helps to go from weeks of pre-training down to a few days. So now we have a pre-trained language model, and the second phase is then, if you want to work in a certain domain, adapted to this particular language that you have. And what you do there is basically continuing the same style of training that we saw before. The only thing that changes what you feed in. You feed now in, not feed in a Wikipedia text anymore, but for example some legal text from contracts. And this is useful if you are working in a domain with some particular patterns, particular abbreviations. In my experience, that actually is the case in most companies. Maybe news is a bit different, but for all others, I've seen there's usually some specifics in the domain. And this phase is already helpful if you have roughly about 500 megabytes of text data. I also saw cases with even 200 megabytes where it gave some boost. So yeah, it's worth trying it in most cases. It also helps, well, it's useful if for your final downstream training, you only have very few training samples. So in contrast, let's say you have downstream task document classification and you have 10 million annotated examples. Then this phase doesn't make sense for you, because in this downstream task, the model will already have enough time to adapt to this domain and learn all the specifics. Then you don't need this intermediate step. If you do this, again, low learning rate, start with that, try to bump it up, have some warm-up. What you can also do here is modifying the vocabulary. So, for example, the standard BERT has around 30,000 tokens in the vocab, and there are 3,000 unused tokens, so basically placeholders. And you can just exchange those placeholders with your own terms that come up in your language. In many companies, that's product names, abbreviations, and so on. What also helped in many projects that we conducted is experimenting with additional tasks. So we have here this next sentence task and language modeling, but in some domains you also have access to additional meta information. So for example, what kind of contract this sentence comes from. And you can do here some classification as a third task. This also then helps to learn more about the domain that you're in. So if you've done all that, we are now in the final phase, downstream. So finally where you really see then the fruits of your work, where you can harvest them. And one exemplary downstream task might be classification. So now you basically take this BERT model from the previous steps, but you remove the predictions heads that we saw before and put instead a classification head on top. This is just usually one or two simple layers of a neural network, and it's very cheap to add this. And then you can actually predict what topic this sentence, for example, is about. These prediction heads are really something like a Swiss knife. You can exchange easily now what task you want to apply this model to. You can put here an identity recognition, question answering, you name it, basically all NLP tasks. So this was now all about BERT, and I think it's still one of the most popular central models that we have out there. But as I said in the beginning, this field is developing at an incredible pace, and there are new language models out there every week. And I think it's not important to understand all of them, but it's quite helpful to see what kind of trends are there. What are the next language models about? So let me put a few of them up here. There was a while ago a model called SpanBERT, And what the authors did there is actually changing the objective of the language model from only masking single tokens to actually masking full span, so multiple tokens. And that was quite an interesting idea. They had some improved performance that they got out of it. Then there was Roberta, published by Facebook. And what they basically did is they took more data, trained for a longer time, using a larger batch size, and they also got rid of the next sentence prediction. And also that one boosted up performance quite a lot. So I think there's also some general pattern for these kind of models. More data usually helps. And then very recently, Google published BERT, which is currently dominating a lot of benchmarks, a lot of leaderboards. And they had also some interesting ideas how to go on with these architectures, what we can change. And what they do is basically they make this model more efficient by sharing weights across different layers, different transform blocks. And they factorize the embeddings. So basically, in the beginning we had, let's say we have a vocabulary of 30,000 tokens. You would have a matrix of 30,000 times your embedding dimensionality. And with this factorization, you basically reduce that to a few matrix multiplications that are way cheaper in terms of memory. And they also varied this next sentence prediction a bit. So we already see here a pattern. This original next sentence prediction of BERT is probably not the future. There's a lot of experiments to change that. The last direction, model size. So these models are quite huge. They usually at least are trained on GPUs. And now there are a lot of attempts to bring them down so that you can actually run them on even mobile devices. And two models there, QBERT and DILBERT, they are really so small that you can run them on on a mobile, and they still have around 90% of performance of the original models. That's not all. There is way more. I won't now go into these details. I will share the slides, of course, and maybe if you look for a language model for your particular task, this might be a good starting point. One topic that strikes me quite a lot is that most of these language models are focusing on English language. So what about non-English languages? What about Polish? What about German? There are these multilingual models, but they are not always working well for your particular language. So we as DeepSet try to promote also these language models in other languages. We trained in open source the German one. We're currently training a German BERT, and we have some collaboration with Google. So if you were interested in, for example, training a model in your language, Polish maybe, please approach me. We're happy to support it with knowledge, with code, and also with GPUs actually in the Google Cloud. So now we know more about these language models. What can we do with them? Let's focus on one task, one application called question answering. And I think it's best explained again with a demo. What is question answering? Also, this demo again is public. If you want to play around with it, just go to this website. And it's all open source, so you can even deploy this UI easily with a Docker on your own infrastructure, put your own models in here, whatever you like. So in question answering, we basically have to put here in one passage or one document, and then we can ask questions that might be answered from this document. And we have some examples up here, but I usually I don't trust these examples, so let's try something different. We're here today at this Copernicus Center, so let's take the wiki article from Nicolaus Copernicus. You can just paste these maybe two passages here. And now we can start asking questions. So, what do we want to know about Copernicus? Maybe what did Copernicus do? And the model then basically scans through the text and tries to identify a span that answers this question. And we find that Copernicus formulated a model of the universe that placed the sun rather than Earth at the center of the universe. Quite an achievement, I would say. So let's try something else. When did he die? So also here, the model basically identifies this date as the date of death, but the word is not mentioned at all. And this is something important that has changed now. Similar question answering systems worked before, but they always relied on really keyword matching or very similar words appearing in this context. And this is now different with these later models. You can also ask, of course, where did he live? In Royal Prussia. And what is that? I haven't heard it. What is Royal Prussia? It's basically a region that had been part of the Kingdom of Poland since 1466. So you see this, you can use this tool to basically dive also into texts, and that's how, I mean, this is right now only on a small passage. What we do now in a lot of projects is actually doing that on large scale, having thousands of documents, huge knowledge base in the background, and having them basically a tool dashboard for people where they can dive in and analyze documents. And as I said, this is all open source. So to summarize that, what is question answering? Basically, question, passage, and you extract an answer out of that. That's what we also call extractive question answering. There's also other variants that are quite interesting right now, where you, for example, want to have binary answers, yes or no, or you want to generate generate answers, so you don't need to have the answers written anymore in the text itself. There's also multi-hop QA, which is like sometimes the answer is in different locations of your document, and you need to aggregate those pieces of information to actually come up with the final answer. And this is all super hot right now. All conferences are basically focusing on that, and there's a lot of publications. So let's look a bit under the hood. I don't have time to go into details, unfortunately, but I think as machine learning engineers, we are usually interested also in the modeling, not only the UI or applications. As we've seen before, we have a model. Let's, for example, take BERT, language model, and now we feed in text. But what we feed in now here is the question, some separation, and then the actual passage, both at one time. And what we get then out of this language model is basically a contextualized token embedding. So for each token down here, we get a vector. We feed these vectors to our prediction head for question answering. And this question answering head then predicts which one is the start token of the answer and the end token. And this gives us then in the end the final span that we convert back to string space. And this is then maybe what is Berlin, the largest city of Germany. What is happening now in this question answering head? As I said, there's vectors per token going into this prediction head, and then it's only a very shallow feed-forward network. It basically has one input layer and an output layer with two neurons. And these two neurons give us logits, some sort of probability for that this token right now is the start of the answer or the end of the answer. And we basically run this feed-forward network for each of the token embeddings. We get the start and end logits for this token, and we apply it for the whole sequence. And this gives us then, in the end, an overview of this whole passage, of the sequence, and we pick the token with the highest start logit and the one with the highest end logit, combine them to our answer in the end. There's one extra token, or specialty I would say. Many cases it's helpful if the model has also the option to say there is no answer in the text. And this is why people add like an extra token in the beginning, so that the model can also predict there's no information in this text, I cannot answer this. And that's pretty much what happens on the modeling side. So also there, if you look into it, it's really, really simple, and there's thousands of things that you can improve. And that's what makes me really excited about this field, because there's still tons of opportunities. So how can you now implement that? Luckily, the NLP community is very open. A lot of code is published and a lot of frameworks are out there. I only will highlight a few of them right now. There's more. One I think that is very popular these days is transformers from Hugging Face. And what they do is basically providing a very large collection of models. So you can be quite sure if there's a new complication, it will be implemented in this library. They have support for PyTorch and TensorFlow, and they have quite some large research community. So if you want to really focus on the modeling side, just take this plain model out there. This is definitely a recommendation. We also started using Hugging Face basically 1 year ago and contributed in this open source community, developed some features. After a while we saw for really applying transfer learning industry, we needed a few more features, and that's why we decided to create an own framework called FARM, also open sourced, and there our focus is really taking these transformer models from Hugging Face, but providing some additional utility layer on top that is more scalable, it's faster, it's easier to debug, and it gives you, I think, most flexibility to actually build very, very fast proof of concepts in the industry and then also bring them into production. And then on top of that, right now we are really excited about QA, question answering. That's why we just, I think, 3 weeks ago, released an additional framework, Haystack, which we now use to do this question answering at scale. So not on a single passage anymore, but at thousands of documents. If you're interested, check it out. It's all on GitHub. Also, I think sometimes if you maybe haven't used these kind of models yet, it might be a bit intimidating, but it's actually, from a code perspective right now, pretty simple. And here's one example how to train a question answering model. It's basically these few lines of code, some data processing before for a data set, the modeling bit, and then the training bit. There's also a Colab notebook here, how to do QA, question answering, and there's tons of tutorials for other frameworks as well. So let's summarize. Key statement for today from my side, transfer learning is working, and it's definitely worth a look for your project if you want to do NLP. It's right now changing a lot, research, industry, but also the style of working. In particular, question answering and these semantical tasks like summarization, they make an incredible progress. And this gives, of course, exciting opportunities for the industry. Self-service on websites. I imagine in the future that also in documents we don't do Control F anymore for search, but maybe Control Q for answering questions. And in particular in knowledge intense domains, science, finance, legal, there's a lot of excitement right now. So what is ahead? I think next steps are probably that we'll see more around model efficiency and stability, so really scaling down those models while keeping the performance. This I think is super exciting and will help to scale them in production. There are also a lot of interesting ideas for new strategies in transfer learning. In particular, I can recommend this paper T5 for Google. The idea is to every NLP task to convert it into a text-to-text task. So you feed in some text and you get out some text, even for classification in ER. And this, of course, is then really like one model to rule them all, and I think a quite interesting direction. Generative QA, briefly talked about that one, and then the end of the road. I think right now, most of these models, all of these models, actually are quite still do pattern matching. Very efficient, powerful pattern matching. And some of you might know this book from Daniel Kahneman, Thinking Fast, Thinking Slow, where he describes basically human thinking. And he differentiates between thinking fast and thinking slow. System 1 and System 2. Thinking fast is all automated pattern matching, learned behavior. If you drive on the highway, after a while you don't really think about what you're doing anymore. While on the other hand, System 2, thinking fast, is really reasoning, thinking slowly about consequences, putting together some puzzle pieces. And this is missing totally right now. There's right now at NeurIPS some discussion panels around this topic, and there's more and more ideas, but I think it's still some time ahead. So if you ask me, would have asked me, like, say 5 years ago, if that what we have today is AI, these question answering models, I probably would have stated, at least it's a good step in this direction. If you ask me today, I would say no, this is not AI. And this is what some people these days now describe as the AI effect, stating AI is whatever hasn't been done yet. And basically every time you figure out how something works, it stops being magical. And you say, okay, yeah, maybe we thought this is AI, but in the end, yeah, humans, they work really differently. And this is only matrix multiplications, right? So I'm not sure if there is really AI. I think this is just an interesting phenomenon that we should keep in mind. That's it from my side. Thanks for your attention. And if there's time for questions, happy to answer them.
Yeah, we have time for questions, like 1 or 2 questions to Malte. Yeah, question here.
Yeah, thank you for the talk. About the question answering systems, I assume it requires annotated data, right?
Sorry?
The question answering require annotated data.
Yes.
So realistically, how much data do you need to build a question answering system?
Yeah, the interesting thing is that the AI can also do transfer learning. So what we do a lot is pre-training a model, for example, on the SWOT data set, which has, I think, around 100,000 examples, and then fine-tuning them on smaller domain-specific corpus.
Okay.
And there, in many cases, we had like 1,000, 2,000 labels.
Okay.
So something that you can get in 1 week, 2 weeks.
Oh, that's great.
And this already gives you a big boost.
Thank you.
All right, one more. It's in the back.
Thank you for the talk. I wonder if you have any experience with cases where the answer for a question might appear multiple times within the passage, like in cases where you take a very long one and it might appear more than once.
You mean the same question in multiple occurrences?
Same answer.
Same answer, yes.
Same answer for this question.
Yes, there's cases like this. I mean, depends on a bit what you return, or like what's your use case, how do you want to present it. You can, of course, return the top K answers out of a document, and then it's up to you what you want to do with that. In some cases where, one case, for example, where financial analysts want to analyze companies, and there we just return, I think, the top 5 answers, and present them also to the user in the end. And that's how then they can also still decide what is correct. But it's also really important not only usually to give back the answer, but also the context. So a bit of the surrounding. yeah, this is also important for trust for the user in the end.
All right, one more? If not, you can probably find Malte over lunch or during the coffee breaks. Okay, thank you so much, Malte.